Hello, my name is David Clidence, President of Oxygen Technologies. Thank you, NALMS, for having me. I'm here to present on a project we did with the City of San Diego in Lake Hodges, California, involving the installation of a Speece Cone in the hypolimnium of Lake Hodges. Very quick presentation outline. We'll speak on ECO2, our company, get into the Speece Cone, how it's designed, Lake Hodges specific, project design and components, some results, and conclusion. Company profile. So ECO2 or Eco Oxygen Technologies is headquarters in Indianapolis, Indiana. It was founded in the year 2000 to commercialize the Speece Cone that Dr. Richard Speece developed in the mid-90s to add oxygen to lakes and rivers for water quality enhancement. We have now partnered with Dr. Speece, who sits on our board of directors and active in the day-to-day business of the company, to enhance this technology and further this technology into both the water quality markets and the wastewater markets. The other gentleman there pictured is Dr. George Shabanagis, professor at UC Davis, who also helps advise us and sits on our board of directors. Yes, ECO2, or Eco Oxygen Technologies, is a US-based company in Indianapolis, Indiana. Most of our installations are in the United States, although we have a few in Canada and in China and Southeast Asia. Longest operating system is over 20 years, about 100 installations to date, and some pretty notable clients: Army Corps of Engineers, City of New York, Dallas, Hong Kong, and others. This particular project, Lake Hodges, is in San Diego, California, and you can see there we have quite a few installations there in Southern California. The subject of this presentation is centered around the Speece Cone shown here. This installation was actually at a wastewater treatment plant on a primary clarifier. But you can see the intake piping connected to the top of the cone, the Speece Cone itself, and then the discharge piping connected from the bottom of the Speece Cone. So the quick technology overview of the Speece Cone. So we are pulling water out of the hypolimnium, running it through a raw water screen, up through a side stream pump, which is a submersible pump. And that raw water then is fed to the top of the cone. Gaseous oxygen is piped into the side of the cone, and that oxygen gas comes in bubble form. So once the bubble enters the cone, it has a buoyant velocity or rise velocity. So that bubble starts rising towards the top of the cone, where the inlet water jet, which is high velocity, pushes those bubbles back down inside the cone. So the bubbles travel to the bottom of the cone, where it reaches the point. And the whole reason that the system is a cone shape is that at the bottom of the cone, the cross section of the cone is wide enough where we're slowing down the water velocity to a point where the bubble rise velocity is higher than the water velocity at that point. So the bubbles then start to rise again, where they rise up to the inlet jet and are pushed back down into the cone. So they're in this circular pattern until they completely dissolve. Once they're dissolved, then that oxygenated water then is discharged out the bottom of the cone back down into the hypolimnium. So schematically, what the system looks like in Lake Hodges is the cone sits on the bottom of the reservoir. It sits on a concrete pad that's formed on a base of stone to support the concrete pad in the cone. We have an intake screen and intake piping for the side stream pump. The side stream pump actually sits inside of a pump tube that can be easily raised and lowered for maintenance. That pump tube then is connected to the top of the Speece Cone to feed the raw water into the top of the cone. We have an oxygen line that feeds the cone. There's a liquid oxygen tank that sits on grade on shore. And there's what we call an umbilical cord that's running from shore that contains both the oxygen line and the pump feed power to the system. So then you have the Speece Cone itself, that's bolted to the concrete pad, and then you have a short diffuser to distribute that oxygenated water to the reservoir. So here's what the system looks like in real life. You can see the system sitting on the concrete pad, and this is on the barge before it is installed. But you have the intake screen there to your left. You have the pump and the pump tube that's connected to the cone with intake piping. You can see the Speece Cone itself, and then the diffuser port. The diffuser is not attached to the cone in this picture, but it will be bolted to that flange on the discharge of the cone. On the next slide, I'm going to show you a YouTube video put on by the City of San Diego and Jeff Pasek describing the background of the project, some of the particulars of the project, why they did the project, and some of the benefits. It's much better hearing from Jeff than it is for me. Hope you enjoy the video.
This is the Hodges Oxygenation Project. We're here at Hodges Reservoir, which is operated by the City of San Diego, along with the County Water Authority. We are building a Speece Cone, and that's a fairly unique method for adding oxygen to a reservoir. There's only a few of them in the world. There's one in Northern California. There's another in a reservoir in Colorado. And this project derived from a planning study that was done about 5 years ago, which identified oxygenation using a Speece Cone as being the most cost-effective way of addressing the water quality problems in Hodges. The oxidation project is intended to put a lot of highly oxygenated water deep into the reservoir, at the bottom of the reservoir, to overcome water quality problems that have been here at Hodges for a long time. The project was funded in part by a state grant and also with money from the City of San Diego. The benefits of the project are that it will improve water quality in Hodges and in connected Levenheim Reservoir, and those reservoirs are primarily for drinking water supply for the San Diego region. It will improve water quality by addressing nutrient loading that causes excessive algae blooms in the reservoir. An ancillary benefit not anticipated when we got started on the project is to address the accumulation of mercury in fish, which can be harmful to people and wildlife that eat the fish from the reservoir.
So we're talking now about the system design. So the Speece Cone was installed underwater. Sometimes they are installed on grade. You get on grade on the shoreline. In this case, the design team thought it was optimal to place the cone on the bottom of the reservoir. By doing that, you get free hydrostatic pressure on top of the cone, so you're able to increase the dissolved oxygen concentration coming out of the cone without increased horsepower. So there's many advantages to setting the cone on the bottom of the reservoir. It's 12-foot diameter, 20-foot tall. It was designed to dissolve 10,000 pounds of oxygen into the hypolimnium. It's installed at 55 foot of depth, and an intake screen was designed so that no more than half a foot per second water velocity across the screens to prevent fish impacting. Brown and Caldwell was the design engineer on the project. Bill Feist and Mark Butel helped in this effort. You can see a picture of Mark and some of the other members that helped with the sediment oxygen demand testing of Hodges that was used in the ultimate design of the oxygenation system. Again, here's the schematic of the system. In the next few slides, I'll go through specific pictures of each component of the system. Here's a picture of the intake screen. Again, this intake screen was sized to limit the water velocity across the face of the screen to less than a half foot per second to prevent fish impingement. Here's the Flygt submersible pump. So there's a picture of the pump to your left, and then the pump tube to your right that the submersible pump sits down in. Here's a picture of the liquid oxygen system and vaporizers, and then the PLC controls there to your right. Here's a picture of the Speece Cone being lifted off the bed of the delivery truck and onto the deck of the barge. So here you can see a picture of the barge. To the left there's the crane, you have the Speece Cone on the right hand side. What's in front of you there in those white bags is actually the aggregate stone that they are going to use to build up the foundation on the bottom of the reservoir that they will ultimately set the Speece Cone and the concrete pad on. Here's another video from the city of San Diego of the installation and sinking of the Speece Cone. In terms of performance testing, the system included some sampling buoys designed and provided by Paul Ganser of Ganser Water. These buoys were incorporated to measure dissolved oxygen, temperature, some other parameters near the bottom in the hypolimneum as well as near the surface. Unfortunately, the project has not been up and running this data by this presentation. Unfortunately, it's not available. So here's that sums up my presentation. Thank you for listening. If you have any questions, I'll be available during the speaker panel, but below is my email and website if you want to reach out to me directly. Thank you.